Snakemake, the second tool on our journey. Let's get things a little bit more complicated and work requiring, but let's try and gain some new capabilities that we couldn't do with Parallel. So the installation of Snakemake is also pretty easy, but not quite as dead simple as Parallel. It is Python based, both in running itself and sort of the user interface to it. So you will need some kind of Python installation on your machine to be using a Python installation on whatever machine you're working on. Yep, so here's the link, Snakemake, readthedocs.io. There's a lot of content in Snakemake. I could take a week of seminars full day and not be able to cover everything. We've got to really sort of pick and choose both basic and demonstrating the broader concept. So I'm missing a lot, but it's in the docs and there's some decent sort of tutorials and follow along an explanation of more of the concepts than I can get to. The easiest way to get Snakemake onto your machine would be using Anaconda to build an environment with it. So get in your Python environment. At NERSC on Perlmutter, you would do a module load Python first, and then create a new environment through the Conda Forge and BioConda channel. Name it something, and Snakemake here is the keyword that gets this particular piece of software. When they do examples, they just name it Snakemake, and then the name of the thing is Snakemake, and you feel like that's might be a little confusing for somebody that doesn't scan that, oh, Snakemake end is the name of the environment you're creating, and the other thing is the actual software going into it. So I try and make that a little more clear here. You can also get it with pip. That's another option for getting it. Pip install Snakemake. And on Perlmutter, as I said, the Anaconda infrastructure comes from module load Python. So once you have it, what is Snakemake? Well, if you really think about it, GNU Make is a workflow management tool. You probably only use it to build software, but building software is a workflow. Maybe it doesn't have expansions into broad swaths of data with, wildcards and different steps. It's just sort of compiling and linking things, but it's doing things in order. It's doing things in parallel. It's using the file system to track its progress and maybe not redo work that it doesn't need to do. Make is a workflow. But it doesn't have the features that you might want that would make it very useful for doing like data processing or computing high throughput tasks. And lots of different people that work on software projects have noted that and made pieces of software to add functionality to the model of Make so that it is more useful for other things. Snakemake is one example of this. I'm aware there's on the order of like 10 different things that is something Make, that is Make-like, but adds sort of different sets of features or interfaces to add more capability to Make itself. In the case of Snakemake, and from the perspective of you're running high throughput workloads, the new capability that you are getting by progressing from GNU Parallel to Snakemake is now you have something that can manage the ordering and dependencies that your tasks get run. You can make sure that if you need to complete task A before task B, you can tell this model to do that and it will. Something that you absolutely can't do in GNU Parallel. What do you have to pay to get that capability? You have to write a different kind of workflow script. The roles files They literally say snake file, like make file. It will automatically find something named snake file if you don't explicitly give it a file. Uh, it's got Python in it, and it also has sort of this rules, dependencies, input, output formatting. Well, you have to do more explicit, and there's a bit more sort of boilerplate-ish kind of stuff to actually build your pipeline to describe it clearly. And the second thing that is a heavier lift with Snakemake is now you're using the file system to both control your workflow, track the state as it's progressing, keep track of what's finished and what's not. All of these file names are sort of the nodes in your graph of what's finished or what's not. If the file name isn't there, then Snakemake knows it hasn't been done yet, and it knows it needs to find rules to try and build that thing. So that's the primary sort of detail distinguishing how data works in Snakemake. Everything is files. There's no existence of anything that is not files. And all of the state is also files. It's basically using your file system metadata servers to keep track of what's done and what's not and what still needs to be done. As a user, when you're building your pipeline, you're writing in Python. And what you're doing is you're describing these rules to explain, for this rule, what's the input you need to do it? What's the output that it will generate when you run it? The name of the file you're getting for doing this particular computational task. And some sort of command or Python script or shell script piece connected to that input and output. That is, how do we turn the input into the output? What commands are we running? How is the script processing things? What's the BWA or the blast that turns the FASTQ into the alignment file? That kind of thing. Once you've finished writing your pipeline and you actually want to do some computation, the way that you interact with Snakemake is you tell it, this is the file I want. You don't give it data that says this is the data you start with and it sort of progresses through things from order. It starts at the other end with the finished product. So you say, I want this completed chart, and the name of the chart is plot.png. So at the top of your snake file, you will have a rule that says the input is chart.png. And that's telling Snakemake that that's the ultimate goal. And what Snakemake is going to do is it's going to record that and say, okay, I need to go down through the list of all the rules here, and I got to find something that if I run it and get the output, it's going to give me plot.png. So it searches through the list of rules until it finds that, and then it sets it to run. And when it chooses to run that, it also has inputs for whatever data has to go into your plot utility to make plot.png. So then Snakemake stops at that rule and says, okay, I need data.text. Where do I get data.text? And it goes back through the rules looking for something that would satisfy the need for data.text. And this scales all the way down until it comes to a rule that either doesn't have any inputs because it just sort of self-generates a file from running, or it finds sort of the actual data that you provided in the right place. And it says, all right, I've got the input and I know that the output I can make from that is in the chain of things to get all the way to my goal. So this is where I'm going to start running. That's how Snakemake thinks on the inside. It does not start out with a plan for this is exactly the order that things go. Your graph is just built out of links, and it matches up sort of the sources and destinations of all the links in your graph on the fly. And if you're running Snakemake and you want to see the logs of what it actually did, So the records of which rules it ran or whether it found any errors, anything like that. Snakemake will make a hidden directory named Snakemake in whatever working directory you ran it, and all of your logs will be in there. So be on the lookout for hidden directories. This is one of those tools that uses hidden directories. Okay. The Hello World equivalent of Snakemake. So I've got a snake file here, and it's got this rule all at the top. That is setting the destination. That is the ultimate product that this is supposed to generate, hello world.txt. And then I've got one rule below it with an output, hello world.txt. So Snakemake gets to this point and it says, oh, I'm looking for that input. I found the rule that does the output. I should run that. And there are no inputs to satisfy here. It is just something it runs itself. So the payload is it just echoes hello world into the file. Now, when I started out writing the example for this, I actually had the output file named as like the pattern I use for example output in all the examples. So you can double check what I got versus what you got if you run the example. And that would actually do a disservice for Snakemake, because if you ask it for hello world, if you ask it for example output.txt in your top thing, you'll run it. It will see that that file already exists because it's the copy that I provide in the repo, and it wouldn't actually run anything. So I have to sort of make sure that the file names are distinct so that you don't get collisions. There is a convention when writing Snakemake files that you should add directories for each kind of rule input output that you have to prevent collisions like that. And it also improves performance, because when Snakemake is searching for options to match an input with an output, if there is a sort of directory, then that limits the place that it might search for possibilities instead of going through all of the files that may be present in your working directory. Yeah. And the actual command to run to set Snakemake in motion is just Snakemake. So the equivalent of typing lowercase make in a directory that has a make file in it. But you do have to put this CORS file, CORS flag. That is a requirement of running locally. You have to tell it a number of cores. I'd like the default to be 1 and it not have to be here like a piece of boilerplate, but this is what we're stuck with. Okay. So getting to a basic example of a dependency. This is the capability you're getting from Snakemake from moving on from GNU Parallel. You need more rules to be able to encode a dependency. So each rule is the relationship between an input and an output. And the construction of this is matching up inputs to outputs in a chain. Confirm my speaking language. No, thank you, Sim. Okay. Yeah, so this is probably one of the, I was a little sleep deprived when I wrote this, so this is a bit of a wacky example. It is a modification of the earlier example. So we're still working with just like an echo of a hello world. But I added this intermediate step that I want to make sure runs after that initial rule that just makes the hello world text. And I want to make it cooler and fancier. And I want to do that by adding X's on both sides, like it's, an IRC screen name or somebody's AIM screen name back in the 90s, that kind of thing. And so the way this is encoded is I tell my intermediate rule, oh, your input is hello world.txt. That is generated by the initial, by the initial rule. So as Snakemake is going through this, it will see cool hello world.txt, knows it wants that. It sees this rule here with the output, cool hello world.txt. All right, that's the rule I want. but that's got an input. So I'm gonna have to check more roles to see where I can get hello world.txt. It moves down a little further. It finds the previous role from the example. It's like, okay, there's hello world.txt. Let's make it. It runs this echo, it generates that text, and then it comes back to the rule in the chain that it marked earlier and says, all right, now that I have hello world.txt, this is the shell script to modify it the way that I'm supposed to. And we are using that input in the command here, and we've got it piping out to the new file name that's being generated here. And that goes up and satisfies dependency. Snakemake declares victory. Yeah, so you're not like giving it commands in order consciously. You're setting up the recipes. How do you get this? How do you get this? How do you get the thing before it? And you can build very complex chains with a lot of detail in that. You can really feel the bioinformatics culture in putting this together as chains of BWA and indexing and mapping and all of these things that are one after the other that somebody always wants to do in a chain for their data. So the main tentpole feature for adding flexibility to Snakemake is what they call wildcards. So wildcards use this bracket notation, and inside that bracket notation, you have some kind of identifier that signifies the wildcard. And you reuse that identifier in other places, and as Snakemake is working on a particular rule, it picks something that satisfies the dependency in the wildcard and says, okay, I am looking for pool alex.txt. That's the example, the first one that I find. So in all the other rules that it checks, it's gonna see the name ID and it's gonna substitute Alex and it's gonna check, is this something that, is this have the output that I need or does it not? And in this way, you get sort of the flexibility that a single rule can be used on multiple different files in the same run because they have different wildcard ID signifiers that are being passed around to mark different places. So down here in the shell, if you're doing the actual Python script or shell script to work with these, you need to use this wildcards dot ID notation to actually get access to that. The direct signifier name is only available in the inputs and outputs. Now, in this script overall, what I want to do is I have a data folder that's in the example, and it's got a number of files in it that fit the pattern of something.txt. Snakemake is really resistant to sort of open-ended wildcards. It wants you to jump through a lot of hoops to actually get access to it. Like a lot of the examples will explicitly say at the top, like the list is sample A, sample B, sample C. And then all of your wildcard definitions come from, it's either A or B or C. If the wildcard sees one of those, that finite list, then it will move on. It doesn't like to leave those open-ended. And so you have to do this extra stuff. And I had to spend some time actually sort of figuring out a good way to do this. So I'm using the Python pathlib, and what it's doing is it's explicitly going to the data directory that is a child of whatever your working directory is. It's iterating through it. And then it's taking each file it finds and it's chopping off both the suffix, the extension, and it's chopping off the sort of any directory root. So in this case, it's the data prefix on it. And then you end up with a list of every file that is in your data directory. And then you go down and use this expand function that is provided by Snakemake as sort of like a syntactic sweetener kind of thing. And you can use that to map the name list that you generated earlier into the name wildcard identifier. And now you have a wildcard identifier that is set up to be all of the files that are in this particular directory. And then things proceed as normal as Snakemake proceeds through all of the rule alls that match all of the files in that directory and goes through the process of reading them out, doing the echo that adds the decoration to the string inside the file, and then outputs it to the output directory with the cool prefix on the name. So I was frustrated that it wasn't easier to get something open-ended because Snakemake really has a bias towards, you know, the names of the files or some finite list of the things you're trying to generate. You're not trying to do something open-ended. You're not trying to do something for every number from 1 to x, and you give the x as a runtime argument or something like that. But, and I've alluded to this earlier, there are good reasons sometimes to combine different workflow tools, especially if particular tools are very good at one thing that you need, and the things that it's bad at can be covered by a different tool that is very good at that other thing that you need. So this example is a combination of GNU Parallel and Snakemake. And the way that I've distributed the responsibilities is GNU Parallel is handling the actual running things in parallel, since there's 3 files in that data folder, so I want to run 3 things. And also pulling out the file names that are in there and modifying them into the token that is just the base file name and giving that to Snakemake. So I've got this script that's just got a parallel one-liner in it. And it will ls into the data file, and each file name is now in the task list that's going to parallel. And it used the modified substitution to break off both the directory portion and the extension. So now you have just the base file name. And it passes that to Snakemake. So Snakemake can take as arguments both a snake file, if it's not named snake file, this one is, so it picks it up by default, and also a rule, like to be the goal rule. So you don't have to define your goal rule inside the script itself. You can make something that's more flexible by passing in an argument that's this is the actual output that I'm looking for. And we've used the GNU parallel substitutions to build this path to the target that we want. So it comes out of data and we're putting it in output. That's the file name we're looking for. And that's exactly the input that Snakemake wants to get. This is the goal. So now we're running 3 instances of Snakemake, and each instance of Snakemake is getting exactly 1 input that it puts into its wildcard. And so the same rule, using name with different values for each one of the Snakemake runs, will substitute, you know, Alex and Bob and whatever the other thing is in there. And so now we just need one rule that matches up here's the input, do the modification, and then put it in the output. Like this is the same rule from the previous example. We just trimmed off both the pathlib stuff at the top and the base rule. So overall, this is much, much less code, and it's much easier to read, and we're playing to the strengths of both of these individual tools. So, you know, if you put in a little bit of extra time to think about strengths and weaknesses, different tools you have available, and how you want to break down your throughput workflow, well, you can get wins like this. Okay. So that is bottoming out on what I had to show for Snakemake. Uh, I have I have less experience with it than Parallel probably shows, with less enthusiasm for it. But I really wanted to get a demonstration that is combining these tools makes sense and can do good things for you if you spend a little time to think about it clearly. And it is possible to uh, you could rewrite this where Snakemake is on the outside and Parallel is on the inside. I wouldn't suggest that. That'll probably make things harder, but it's totally possible. You can rewrite this with srun on the front, on the back, and there are different reasons to put the different composition of these things, uh, depending on what your workflow is shaped like and your data is shaped like, and on and on and on. Okay. Uh, Jeffrey, are you ready to take over?
Yeah, yeah. It is a quarter after. We got what, an hour and 45 minutes left. So it's not too long since our last break. So I don't really, I don't know that we need to take another break before the next section. How do you feel about that?
Uh, I don't think if you'd like to. Well, you did mention that you had some sort of optional content that you'd like to get to if you could. So
Yeah,
maybe you want to call a cut in the middle of what you're doing at a good spot, and that'll be how we do.
sure. Cool. All right. Do you want, yeah, there we go. Okay. I'll steal this.
No, we set it up so you could steal it, so that wasn't even necessary.
All right. So,